An infinite scene is unfurling as we talk, spellbinding stargazers around the world. Betelgeuse, the entrancing red supergoliath that enhances Orion's shoulder, is going through an exceptional transformation. This heavenly monster, known for its splendid red tone, has been a foundation of the winter sky for centuries, drawing the awe and wonder of stargazers from ancient civilizations to modern astronomers. What makes this change so unprecedented isn't simply the changes happening inside the star itself, but the sheer scale and speed with which they are occurring. This gigantic star, many times bigger than our sun, is showing us just how dynamic and erratic the universe can be. Betelgeuse's glow, the brilliant sparkle that characterizes its heavenly presence, has surged past its usual brightness by a bewildering half. Imagine a light suddenly burning twice as bright, casting its glow further and with greater power. That's what's happening with Betelgeuse on a cosmic scale. At the beginning of this year, Betelgeuse proudly held the distinguished title of the 10th brightest star gracing our nighttime sky. Its consistent natural light was a steady beacon of security. However, this unexpected divine glow-up has propelled it to an esteemed new position, currently shining splendidly as the 7th brightest star in our amazing evening sky. This leap in brilliance has sparked excitement and interest within the astronomical community, prompting new observations and studies to understand the mechanisms driving this dramatic change. Betelgeuse, a huge star in its late stages of life, is of massive size. Its dimensions are so immense that if it were situated at the center of our solar system, it would extend as far as Jupiter's orbit. Eventually, this star will undergo a collapse resulting in a powerful supernova explosion, which may lead to the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's supernova originates from the fact that it will be an extraordinary event. Positioned around 650 light-years away, mankind finds itself in an ideal location to witness this cosmic spectacle firsthand. When the heavenly blast occurs, it will produce a stunning display of light. Initially, there will be a sudden surge of neutrinos that will sweep across the Earth, detectable by observatories worldwide. Following this, as high-energy photons escape from the expanding cloud of stellar debris, Betelgeuse will rapidly intensify in brightness over the course of a week, reaching up to 100,000 times its normal luminosity. Depending on the blast's intensity, this celestial beacon could match the brightness of a full moon and might even be visible during daylight hours, casting distinct shadows at night. This glorious event will endure for a prolonged period, offering a robust opportunity for detailed observations and potentially groundbreaking discoveries. While the supernova of Betelgeuse might trigger speculation and concern due to historical associations of such events with ominous signs, we can take comfort in the fact that we are safely positioned at a considerable distance, protected from any adverse effects. To fully understand the mystery surrounding Betelgeuse, it is crucial to revisit the end of 2019 when peculiar phenomena began to manifest. During this period, the red supergiant star started experiencing significant dimming, a change noticeable even to the unaided eye. Observations using the Very Large Telescope in the optical range revealed that Betelgeuse appeared mostly uniform, though its photospheric layers showed signs of significant disturbance. In our view, the photosphere represents the outer layer of the star where light is emitted. Experts also identified an expansion of the photosphere, giving the impression that the star was enlarging when seen from Earth. This growth continued at a steady rate of around 8 kilometers per second for most of the year until mid-November 2019, at which point the outward velocity began to decline. By mid-November 2019, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical images of the star. Their observations revealed two astonishing anomalies. Firstly, a darkened region appeared in the star's southern hemisphere, creating a stark contrast with a previous image taken at the start of the year. Secondly, the surface temperature of the star experienced a drop, decreasing by around 80 Kelvin between January 27th and February 13th, 2020. Betelgeuse's brightness reached an unprecedented low roughly a year after the cessation of the outflow. However, the star gradually regained its brightness over the following months, eventually returning to its normal magnitude. This led to the question of what had actually happened with Betelgeuse. All the available evidence strongly suggested that Betelgeuse had undergone a massive and rare event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better understand SMEs, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior surges up and outwards, causing shock waves within its atmosphere. Over time, this material forms molecules and dust, partially obscuring our view of the star and making it appear dimmer. In the case of Betelgeuse, the SME resulted in the ejection of a mass 400 billion times greater than what is typically seen during similar events on other stars or CMEs. This amounted to multiple times the mass of the Moon expelled at astonishing speeds. Scientists noted that such a gigantic mass ejection from a star's surface had never been observed before. The event allowed for the direct observation and assessment of surface details using the Hubble telescope, offering a continuous glimpse into the aging and evolution of a dying star. The SME had a profound impact on Betelgeuse, causing it to lose a significant amount of mass in a single event. This incident demonstrated how a dying star can experience considerable mass loss beyond its usual annual reduction due to stellar wind. In a way, it was as if Betelgeuse had violently expelled its upper layers and was now in the process of slowly recovering from the aftermath of this event. However, following this dimming event, the star's behavior has undergone a change. Previously, it would pulsate or alter its brightness every 400 days, but now it is pulsating every 200 days. Betelgeuse is classified as a semi-regular variable star, meaning it experiences different cycles of varying brightness due to changes in its size and temperature. This red supergiant is known to display 2 Ma in periods of light pulsation. The first period lasts 400 days and is believed to be caused by pulsations in the fundamental mode. The second period is a longer cycle of approximately 5.6 years, and its origin remains unknown. In their research paper, scientists utilized virtual simulations to gain a deeper understanding of the events that occurred. They suggested that an unusually hot gas current resembling a large and intense bubble rose from within the star. These occurrences of hot gas bubbles periodically arise due to the star's turbulent and convective envelope, which can be compared to a pot of boiling soup where the material is constantly moving and mixing. As this hot bubble rose and broke through the star's surface, it triggered the ejection of stellar material. Intriguingly, it also disrupted the star's usual pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the star to transition from its usual 400-day pulsation to a new 200-day pulsation. Astronomers anticipate that the star's regular motions will gradually stabilize, returning Betelgeuse to its normal 400-day pulsation over the next 5 to 10 years. Regarding the likelihood of a Betelgeuse supernova, astronomers estimate that it could happen anytime within the next 10,000 to 100,000 years. Based on factors such as the star's color, brightness, size, and estimated age, researchers suggest that Betelgeuse is currently in the early stages of helium to carbon fusion. This process will continue through oxygen, silicon, and finally iron before the star's core collapses under its own gravitational pull, leading to a catastrophic explosion. Since Betelgeuse is located 650 light-years away, any supernova event happening now would only become visible to us after 650 years due to the limits imposed by the speed of light. Consequently, it is highly unlikely that we will witness the star's dramatic demise during our lifetime. The remarkable thing about Betelgeuse is that we can actually see its surface, which is not the case for most other stars. This provides us with an incredible opportunity to learn about how massive stars like Betelgeuse behave as they age, including these types of extraordinary mass ejection events. Recently, astronomers made a startling discovery. For the first time, they observed a star consuming its own planet 12,000 light-years away in the constellation Aquila. Betelgeuse, with its fascinating name and prominent position in the night sky, has captivated the human imagination for centuries. Its significance extends beyond scientific knowledge, as it has influenced popular culture and mythology around the world. Betelgeuse has a rich and diverse origin rooted in the Arabic language, initially translated as the armpit of the giant. Some researchers argue that it might represent a hand or shoulder instead. This physical association is reflected in various interpretations of Betelgeuse, often linked to human or animal figures across different cultures and mythologies. Betelgeuse carries diverse meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil, it was seen as a turtle's leg or a caiman's hind leg. The Sanskrit term for Betelgeuse means the moist one, tied to Hindu astrology's Ardra lunar mansion and associated with the storm god Rudra. Throughout history, Betelgeuse has played a significant role in cultural practices and traditions. For instance, in Macedonian tradition, it symbolized domesticated animals and agricultural life in villages. In other regions, like North Baffin Island and the Melville Peninsula, its rising marked the beginning of spring and longer days. Betelgeuse's cultural prominence stems from its association with the constellation Orion, regarded as one of the most recognizable and culturally significant patterns in the night sky. This alignment has contributed to Betelgeuse's importance in human history, storytelling, and the arts. The interest in Betelgeuse has grown further in recent times, driven by its dramatic fluctuations and changes. Modern telescopes and technologies enable astronomers to capture detailed images and data, allowing the public to witness its transformations in real time. Whether through news articles, documentaries, or social media, people worldwide are increasingly aware of Betelgeuse and its place in our cosmic narrative. If Betelgeuse were to explode in our night sky, it would be an awe-inspiring sight, captivating people across the globe. This unprecedented event would not only provide valuable scientific data, but also foster a sense of wonder and curiosity about the universe. It would serve as a powerful reminder of our place in the cosmos and the dynamic nature of the stars that light up our night sky.